Hello everybody and welcome to the video notes for the review day number 4, our last day of review. And in these set of problems we're talking about volume. I'm going to be going over problems 1, 3, and 5 in this video. Let's take a look at our notes at the top. Volume, whenever we talk about volume in math, what that means is imagine a 3D shape. So for example, we can have this 3D box on the right. And the volume of this box is all of the space inside of it. So if you imagine like if it's all of the air inside of it, that makes up the volume of the shape. Or like if you filled it with water, that the amount of water that you need to fill this box, that would be the volume. And the way that you can calculate the volume is we're going to take the area of the base. The base of this box right here is this part right here. That bottom layer, that's the base. And the base is just a rectangle. So its area is the length times the width. So the area of the base is going to be equal to, here, 5 times 3. And that equals 15. And then it's this base, the area of the base, times the height, which is this guy right here, which is 10. So then if the height is 10, I can do 15 times 10, and I would get 150. And my units are centimeters. And since I'm multiplying centimeters by centimeters by centimeters, it's centimeters to the third power, or centimeters cubed. So my final answer is 150 centimeters cubed is the volume of this box right here. So it's the area of the base times the height. Another way that you could find the volume is if you just multiplied the length times the width times the height. That would have been 5 times 3 times 10. That gets you the same answer of 150. Let's look at problem number 1. What is the volume of the prism below? So if you remember, it's area of the base times the height. So let's find the base. The base is this bottom layer right here. It's this width times this length, or this length times this width, which is 4 times 3. That's the area of that bottom rectangle. And 4 times 3 is 12. And then the height, which is here, is times 9. So we're going to take the area of the base, which was 12, times 9. And 12 times 9 is 108. We were multiplying centimeters times centimeters times centimeters, so that would give us centimeters cubed. So the little 3 up top, just like that. 108 centimeters cubed is our volume. Okay, now that I've done that one, you can use this same strategy to solve number 2. I'm going to move on to number 3. Number 3 says, select all, so we're going to select multiple answers probably, the measurements that could represent volume. Okay, so anytime you're trying to figure out what could be volume and what could not, I want you to remember that area is what you're finding when you're finding a 2D shape, like the area of a circle or a rectangle. And area is always the units squared. So like a little 2 at the end. Volume is whatever the units is cubed with a little 3. Sorry, that's not very clear. I'm going to go over it with another pen so you can see that this is a 2 and that's a 3. So all you have to do is go through these answer options. If it's units cubed with a 3 at the end, then you're talking about volume. If it's units squared with a 2 at the end, you're talking about area, which is 2D, but you want 3D for volume. So for example, 20 inches cubed, that works because it's cubed. 50 millimeters squared, squared is area, so that one doesn't work. 100 feet squared, that doesn't work either, we want cubed. 0.75 kilometers cubed with a 3 at the end, that works. So A and D can represent volume, but B and D represent area instead. Using this same strategy, you can try number 4. I'm going to move on to number 5. A toy factory designed a new container in the shape of a rectangular prism. A rectangular prism is just the math way of saying a box like this. This is a rectangular prism. And the rectangular prism is 12 centimeters tall, okay, with a base dimensions of 4 centimeters by 8 centimeters. Okay, so we have the 3 dimensions we need. And then the edges of a toy in the shape of a cube measure 4 centimeters. So we have a box, and then we're putting toys inside the box. In the first response box, enter the volume. Okay, so here's where we're going to enter the volume in cubic centimeters of the rectangular containers. In the second box, enter the number of toys that would fit inside the box, inside the container. So the second one is where we want to figure out the number of toys that fit inside of it. Okay. To solve this, it's going to help if we draw out our shape. So we have a rectangular prism. The way that you can draw that is start by drawing a rectangle just like this. Okay, and then I'm going to draw these lines just like this. I'm going to connect this to this, connect this to this. Now I have my 3D box, and if you want, you can draw a dotted line going down here, dotted line this way, and a dotted line just like that. And there's our 3D box, or a rectangular prism. And we can label our dimensions. It tells us up here that it's 12 centimeters tall, so we know that this side is 12 centimeters. That's how high it is. And then the dimensions of the base are 4 centimeters by 8 centimeters. So we're going to have a 4 here, and then an 8 here. Okay, so first we have to figure out what is the volume of this rectangular prism container. And remember, volume is area of the base times the height. So for this, the base is going to be all this down here, which is 4 times 8, which equals 32. And the height, which is up here, is 12. So I'm going to multiply this base times the height. So 32 times 12. Two times 2 is 4. 2 times 3 is 6. Next one. Add a 0. And then 1 times 2 is 2. 1 times 3 is 3. And then I can add these two numbers. 4, 6 plus 2 is 8, and then 3. So 384. So I know that the volume of the container is 384, and it's centimeters cubed. I don't have to put centimeters cubed in this answer box here because it already says in the first response, in the first box, in cubic centimeters. So it's already in cubic centimeters, so I just have to put the number. Now, the second part's a little bit trickier, but once you know how to do it, it's not too bad. In the second box, enter the number of toys that would fit into the new container. So we have to figure out how big are the toys, which it tells us right here. The edges of a toy in the shape of a cube measure 4 centimeters. So we have a cube, and each side of the cube is 4 centimeters. So that means if I have my toy over here, right, it's in the shape of a cube, so I can draw a square, like that. Draw these lines again. Right, here's my toy. And each side of this cube is 4. So it's 4 by 4 by 4. Which means to find the volume of the toy, I have to multiply. This is the toy. Right, the base of the toy is 4 times 4, which is 16. And then the height is also 4, so then I have to do 16 times 4. 4 times 6 is 4, carry the 2. 4 times 1 is 4 plus 2, which is 6, 64. Okay, now I know that the volume of the toy is 64 centimeters cubed. And then to figure out how many toys can fit inside the box, how many toys can fit inside the box, I know that the volume of the box is this, and the volume is 384, and the volume of the toys is 64. So what I have to do is, sorry, I should have given you a lot more space to do this problem, is I have to do 384 divided by 64. This is the volume of the box. This is the volume of the toy to see how many toys I can fit in this box. And after you guess and check a little bit, it looks like it's going to be 6, right? 6 times 4 is 24. 2 times 6 is 38. Yep. 6 toys can fit in that box. So 6 toys in the box. Okay. Sorry that was a little bit long, but if you stick with it, you got all that, and then you can use that same strategy to solve number 6 on the right. If you need another piece of scratch paper, you can use page 4 in your packet.